Dear students, hearty welcome to today's module. In this modules, we discuss the determination of surface tension by capillary rise method. We have different methods for the determination of surface tension. They are capillary rise method, Douinois method, bubble pressure method, drop formation method, sessile drop method. Here we have different methods. That is, first one is capillary rise method, second one is drop formation method, then third one is Douinois method, fourth one is sessile drop method, and finally bubble pressure method. Here we discuss the determination of surface tension by capillary rise method. I hope you all know that what is surface tension now. That is the inward pull of the surface molecules by the interior force. So because of the surface tension, the molecules at the surface will try to reduce the surface area. And last class, we saw the different consequences of surface tension. They were the spherical shape of the liquid drop. Second one was the capillary action and meniscus formation. And third one, water spreads but mercury maintains as a drop. That were the different consequences of surface tension. Today, we discuss the determination of surface tension by capillary rise method. So, before we go for the capillary rise method, how we determine the surface tension by capillary rise method, we have to know what is capillary action. That is, capillary action is nothing but when we place a capillary tube. Capillary tube means a glass tube with the internal diameter. In a liquid, according to the nature of the liquid, the capillary action or the capillary fall or capillary rise will happen. That is known as capillary action. Once again, I repeat, when we place a capillary tube, that is a glass tube with the internal diameter upright in a liquid, what will happen? Either the capillary rise will happen or the capillary fall will happen. This depends upon the nature of the liquid. This is called it as capillary action. As we see here, when we place a capillary tube in a liquid, what will happen? After some time, we can see the capillary rise if this liquid is water. So what is the reason for this capillary rise is that we know that the glass is made up of silicon dioxide and water molecules are nothing but H2O molecules. And the adhesive forces between the water molecules and the silicon dioxide is higher than that of the cohesive force between the water molecules. Because of that, the capillary rise will happen. So once again I repeat, the attractive force or the adhesive forces between the water molecules and the silicon dioxide molecules are stronger than that of the cohesive forces between the water molecules. Because of that, the capillary rise happens. Then, this is the angle which formed by the glass and the curved surface. The angle between the curved surface and the glass is called as contact angle, that is theta. If this capillary rise happens, this theta will be less than 90 degree. And the meniscus form is concave meniscus. That means the middle will be downward and the edge will be upwards. Okay, this is about the capillary rise. So now we have to see how we determine the surface tension by capillary rise method. I hope you understood what is capillary rise. Capillary rise, that is nothing but according to the nature of the liquid, if we put some capillary tube, that is nothing but a glass tube with the internal diameter upright in a water, either the capillary rise or capillary fall will happen. If it is water, that will be capillary rise. And the angle between the curved surface and the glass tube is called it as contact angle. And for the capillary rise, this contact angle will be less than 90 degree. This is an introduction of the capillary rise. Now, we have to see how the surface tension is determining by capillary rise method. Here, the liquid, from the liquid to the capillary rise, that is called it as h. That is the height of the tube, capillary tube. Then here we have, this is the contact angle, that is theta. This angle is less than that of 90 degree. And this gamma is the surface tension. And we know that if this is gamma, it has a vertical component, that is gamma cos theta, and this is the horizontal component, that is gamma sin theta. The vertical component, that is gamma cos theta, and the horizontal component, that is gamma sin theta. And if this angle is theta, this angle will be theta only. This angle and this angle will be same. Therefore, since this theta, this angle is theta, this angle also will be theta. Then we have to see how this gamma cos theta and gamma sin theta came. So we know that sin theta is nothing but opposite side by hypotenuse. Opposite side by hypotenuse. So, to find out sin theta, if this is A and this is B, this opposite side, this is the theta, so this is the adjacent side, and this gamma will be the hypotenuse, and this is the opposite side. So opposite side, if this is B, this side will be B, this is A, and this side will be A. Therefore, the opposite side is B is by gamma. Therefore, B is equal to gamma sin theta. The same way, A is equal to gamma cos theta. Okay. And the radius of the capillary tube is R. The radius of the capillary tube is R. Now, the total surface tension along the circular contact line of the meniscus. Meniscus is nothing but the curved surface. The total surface tension along the circular contact line of the meniscus is 2 pi r times. 2 pi r is nothing but perimeter of the circle. So, the total surface tension will be the circular contact line of the meniscus, that is 2 pi r times. Therefore, the upward force, you have to find out the upward force. So, this is the upward force, surface tension, this is the upward force. This upward force is nothing but the perimeter into gamma cos theta, that is 2 pi r into gamma cos theta. Okay, this is the upward force. Then, where this r is the radius of the capillary. This is r, this is gamma. This r is the radius of the capillary, and this gamma is the surface tension, and cos theta is the angle. Then for most of the liquids, this theta is 0. Theta is 0. That means if we take water, the theta will be 0. That means theta is less than 90 degree. Therefore, in the case of water and most of the liquids, theta is 0. Then cos 0, we know that cos 0 is 1. Therefore, the upward force, here we have the upward force, that is 2 pi r gamma cos theta. Since theta is 0, cos theta will be 1. Therefore, the upward force will become 2 pi r gamma. 2 pi r gamma. This is the upward force. Now, we have to find out the downward force. The downward force on the liquid column is due to the weight. The downward force of the liquid column will be due to the weight. Then we know that the downward force is nothing but mass into acceleration due to gravity. Force is nothing but mass into acceleration due to gravity. That is written here, mass into gravity. The downward force is equal to mass into gravity. Now, we have to find out the mass. We know that density is mass by volume. Density is mass by volume. We can write this density as rho. Rho is equal to mass by volume. Therefore, mass is equal to, therefore, we can write this mass as volume into density. Volume into density. Mass is equal to volume into density, that we substitute here. Therefore, the downward force is equal to volume into density into gravity. The downward force is equal to volume into density into gravity. Then, volume. Volume, we know that volume is length into breadth into height. In the case of circle, that is the cross-sectional area into height. That is the cross-section area into height. Then the density will be same and the gravity also remains same. Therefore, the downward force is equal to cross-section area into height into density into gravity. In the case of circle, the area is nothing but pi r square. Area is pi r square. Therefore, the downward force is equal to pi r squared into h into rho into g. That is pi r squared, that is cross-sectional area, height, that is h, then density, that is rho, then gravity, that is acceleration due to gravity. This is the downward force. So now we have the upward force and the downward force. The upward force is 2 pi r gamma and the downward force is pi r square h into rho into g. But at equilibrium, what will happen? The capillary rise will stop. At equilibrium, the capillary rise will stop. That time, the upward force is equal to the downward force. Therefore, we can write it as 2 pi r gamma is equal to pi r square into h into rho into g. That is, once again I write here 2 pi r gamma is equal to pi r square into h into rho into g. This is the upward force. This is the downward force. Now, we can cancel the equal terms, that is pi and pi can be cancelled. Then one r will cancel and here this square will cancel. Then we have the gamma, that is the surface tension, that is r h rho g by 2. This is the surface tension. The surface tension, that is written here, the surface tension gamma is equal to 1 by 2 r h rho g. 1 by 2 r h rho g. This is the surface tension. Gamma is equal to 1 by 2 r h rho g, where h is the height of the liquid in capillary in centimeter and r is the radius of capillary in centimeter and rho is the density of the liquid in gram per centimeter cube and g is the acceleration due to gravity in centimeter per second square. So this is about the surface tension, determination of surface tension by capillary rise method. So once again I repeat, first what we have to do, we have to find out what is the upward force. So upward force is nothing but the perimeter into the vertical component. That is 2 pi r into gamma cos theta. Then for most of the liquids, since the theta is 0, cos 0 is equal to 1. Therefore, the upward force will be equal to 2 pi r gamma. Then we have to find out the downward force. Downward force means force we know that is mass into acceleration due to gravity. We know that density is nothing, density rho is equal to mass by volume. From that we can calculate the mass, that is rho into V. Rho into V, and that is that V is nothing but the pi r square into h, pi area into h, then this area into h into density into gravity, that is the downward force at equilibrium. When the capillary rise stops, the downward force will be equal to the upward force. So what we have to do, the 2 pi r gamma is equal to pi r square into h into rho into g. So when we cancel the equal terms, we will get the surface tension. That surface tension gamma is equal to RH rho g by 2, where r is the radius of the capillary, h is the height of the liquid in capillary, and rho is the density of the liquid, and g is the acceleration due to gravity. This is about the surface tension determination by capillary rise method. Then, if we have two liquids with a different surface tension, then we can find out, if we know the surface tension of the one liquid, we can find out the surface tension of the other liquid. That equation also we can find out by this equation, that is, we know that this gamma 1 is the surface tension of the one liquid, then the equation becomes 1 by 2 r h1 rho 1 g. This radius of the capillary and acceleration due to gravity is not changing, but the height of the capillary tube and the density of the liquid varies. Therefore, for the first liquid, the h1 is the height of the capillary tube and rho is the density of the liquid. And for the second liquid, that is the rho 2, that is the surface tension of the second liquid, then the equation becomes 1 by 2 r h2 rho 2 g. This radius of the tube and the acceleration due to gravity is not changing, and here the height of the liquid and the density of the liquid varies, because here the height of the liquid, the rise of the capillary tube will be different compared to the other liquid, and the density of the liquid also will be different. Now we have to see gamma 1 by gamma 2. So that is similar terms we can cancel. So this 1 by 2 will get cancelled, this also will get cancelled, this r and this r will cancel, then this g and this g will cancel, then gamma 1 by gamma 2, this also gamma 2, gamma 1 by gamma 2 is equal to h1 rho 1 by h2 rho 2. Gamma 1 by gamma 2 is equal to h1 rho 1 divided by h2 rho 2. If we want to find out the rho 2, that is the surface tension of the second liquid, the equation will be, we can cross multiply, then the equation will be rho 1 into h2 rho 2 by h1 rho 1. So if we know the surface tension of the one liquid and to find out the surface tension of the other liquid, we can use this equation, that is gamma 2 is equal to gamma 1 into h2 rho 2 by h1 rho 1. So this is the equation to find out the surface tension of the second liquid. If we know the surface tension of one liquid and we know all other parameters like the height of the capillary tube, density of the liquid, of density of both the liquids. Now let us discuss one problem, that is a capillary tube of internal diameter 0.21 millimeter is dipped into a liquid whose density 0.79 gram per centimeter cube. The liquid rises in this capillary to a height of 6.30 centimeter. Calculate the surface tension of the liquid. G is given. So, the data is given. The capillary tube of internal diameter means 2R is given, that is 0.21 millimeter. So, R is in, as we discussed in the surface tension determination equation, R is the radius of the tube in centimeter. Therefore, we have to convert this millimeter into centimeter. First, we have to find out the radius of the tube, that is 0.21 by 2. So, this is the radius of the tube. Then, to convert this millimeter into centimeter, we have to divide by 1 by 10. Then, this will be in centimeter. Okay. Then, it is given. It's dipped into a liquid whose density is 0.79 gram per centimeter cube. So, density rho is given, that is 0.79 gram per centimeter cube. So, I hope you know that we can write it as gram per centimeter cube like this, and we can write it as like this also. Okay. See, this is the density. Then the liquid rises in this capillary to a height of 6.30 centimeter. Therefore, H is 6.30 centimeter. We have to find out the surface tension. That is the question. And another data is given. G is equal to 980 centimeter per second square. This is given. So, now we have to find out the surface tension. We know the equation to find out the surface tension, that is gamma is equal to 1 by 2 R H rho G. 1 by 2 R H rho G. So, we have to substitute all the values here, that is 1 by 2, rho is 0.79 gram centimeter cube, H is 6.30 centimeter, then density is 0. This is R, sorry, this is 1 is R, this is R. So, here we have to, this is R. So, instead of R, I have written here the density, that is 0.79 gram centimeter cube. This is R. So, here R is 0.21 by 2 into 1 by 10 centimeter. Then G also is there. This G is 980 centimeter per second square. So, this is the equation. So, we have to substitute, we have substituted all the values. When we do the calculation of 0.79 into 6.30 into 0.21 divided by 2 into 1 by 10 into 180, the whole divided by 2. So, when we do this calculation, we will get the value as around 25.6, and here we have 1 centimeter, here we have 1 centimeter, and here we have 1 centimeter, and here we have then that centimeter, all centimeter, then we have 3 centimeter, therefore that is centimeter cube. And here we have centimeter cube inverse. So this centimeter cube inverse and this centimeter and this centimeter and this centimeter also get cancelled. Finally, we have the answer 25.56 gram per second. This is the answer. The answer is given in dyne per centimeter inverse. That is 1 dyne. Our answer is 25.6. Our answer is 25.6 gram per second square. So 1 dyne is 1 gram centimeter per second square. Therefore, there is no change the value, there is no change for the value, that is 25.6 dyne. Then the gram and that got cancelled and we have the centimeter here, therefore this will become centimeter inverse. This will become centimeter inverse. So once again that I will tell, that is here we have 1 dyne. 1 dyne is equal to gram centimeter inverse. So we have to convert this gram per second to dyne. Once it comes this side, it will become centimeter inverse. That is how the answer comes like 25.6 dyne centimeter inverse. I hope you understood this problem. So in this module, we saw the determination of surface tension by capillary rise method. We have an equation to find out the surface tension by capillary rise method, that is gamma is equal to 1 by 2 RH rho g, where gamma is the surface tension of the liquid, R is the radius of the capillary, H is the height of the liquid, and rho is the density of the liquid, and G is the acceleration due to gravity. Then we saw that to find out the surface tension of the second liquid, if we know the surface tension of the one liquid and all other parameters, then we discussed one problem in this module. I hope you understood the determination of the surface tension by capillary rise method. Thank you.